Hi folks, so we're looking at number 15 from page 107. So we're given these two limits, and then we're asked to find these three limits here. So the first thing we have to do is find the limit of f at x as x approaches 0. So I'm going to focus my attention on this first limit that we're given, and we're told that f at x over x approaches 1 as x approaches 0. So this limit exists, but this is where I want you to notice that the denominator is approaching 0. And the only way for this limit to exist, if the denominator is approaching 0, is if the numerator also approaches 0. Okay, if the numerator is approaching a real number and the denominator 0, this limit could not exist. The only way for it to possibly exist is for this to be an indeterminate form. Therefore, both numerator and denominator approaching 0. So from that argument, we can just say that this limit must approach 0. Okay, since limit as x approaches 0 f at x over x, must be an indeterminate form. For the limit to exist. Okay, we can make the exact same argument for the second one, because here we have another limit where the denominator is approaching 0, yet the limit exists, meaning the only way for this to occur is if it's an indeterminate form. Therefore, the limit of g of x as x approaches 0 also has to be equal to 0. Okay, so we can make the same argument here. I won't rewrite it. Now, let's look at this third one here. So, what I cannot do is I certainly cannot split these up using our limit properties, because even though each limit exists, we know that in order to use the limit properties on a quotient, the limit of the denominator can't be 0. So we can't deal with it this way. Okay? We also know, though, that this is an indeterminate form because both the numerator and denominator are approaching 0 based on what we saw earlier. So it means this limit may exist. Okay? Normally we would perform some kind of algebra in order to see if the limit existed, but there's really not much we can do since we don't know what the equations of these functions are. But we do have these given limits. So this is where you have to think, how can I take this expression, f at x over g at x, and make it incorporate these two expressions, which I do know the limit of. Okay, and again, a trick that you've seen in advanced functions is I need f at x over x and I need g at x over x. So what I can do here is just divide both numerator and denominator by x, which I'm allowed to do since I can multiply or divide the numerator and denominator of any fraction by the same amount, as long as it's the same amount. I can do that. Here, I don't have to worry about x being equal to 0, because the only thing I'm interested in is when it's close to 0. Okay, so we can rewrite this. Limit as x approaches 0 of f at x over x divided by g at x over x. Okay, but now I can use the division rule from the property of limits, because this approaches a real number, that approaches a real number, and the denominator does not approach 0. So that means we can apply our properties of limits here on quotients. So I can rewrite this as the limit as x approaches 0 of f at x over x divided by the limit as x approaches 0 of g at x over x. Again, please keep in mind, I can only do this because both limits exist and the limit of the denominator is not equal to 0. And now from here, I'm given these values. The numerator approaches 1 and the denominator approaches 2. And there we go. There's our final answer. Okay, that's it for this one.